Your phone can pinpoint your exact location thanks to the Global Positioning System or GPS. But how does this technology work? Behind the scenes is some simple math. Let's dive right into it. To tell any location, we often use reference points, like saying that a cafe is near a grocery store or opposite the park. But these can be subjective, vague, and imprecise. So what's a better way to share any location without relying on such reference points? To answer that, let's simplify things by imagining a 2D world and use this flag as a fixed reference point. If I tell you that I am at 10 meters from the red flag, could you locate me? I could be 10 meters in this direction or here, in fact anywhere on this circle. So just knowing that I am 10 meters from this flag is not enough. Let's bring in another flag. If I also tell you that I am 20 meters away from the blue flag, is this enough to locate me now? Being 20 meters from the blue flag gives another circle of possible locations. But to be 10 meters away from the red flag as well as 20 meters from the blue one, I could only be at either of these spots. Down from many possibilities to just two, but still not precise. To pinpoint my exact location, we will need a third flag. Say I tell you that I'm 30 meters from this green flag. We get another circle of possibilities. But the only point that is 10 meters from the red flag, 20 meters from the blue flag, and 30 meters from the green flag is this, where the three circles intersect. That's my exact location. No other point can be 10, 20, and 30 meters away from these three flags respectively. By the way, we call this set of numbers or distances 10, 20, 30 as my coordinates. Every other point on this 2D world will have a unique set of coordinates. Like this point has the coordinates 25, 30, 10, and the point with coordinates 15, 25, 20 must be this one. So if we have three reference points and I give you a set of three numbers which tell my distance from each point, you can always locate me in this 2D world. What about our real 3D world? In this case, the reference points are the satellites circling the Earth. Your smartphone communicates with some of these satellites and calculates its distances from them. How? Satellites send signals with timestamps, which are accurate up to a billionth of a second thanks to the atomic clocks they use. GPS receivers in your phone pick up these signals and look at the difference between the sent and received times. By multiplying this time with the speed of light, we get the distance between your phone and the satellite. So how many satellites do we need to know your exact location? Say we have just one satellite and your phone knows that you are 12,000 miles away from it. Is that enough to locate you on Earth? There are many points that are 12,000 miles from the satellite, forming a sphere, and you could be anywhere on this sphere. So, one satellite is not enough. Suppose we add another satellite and your phone detects that it is 13,000 miles away. Now you could be anywhere on the surface of this sphere. Considering both distances, you can be anywhere on this circle, formed by the intersection of these two spheres. We are down from a sphere of possibilities to a circle, but still not enough. Let's bring in a third satellite. If you are, say, 14,000 miles away from it, we get another sphere of possible locations. This sphere intersects the previous circle at two different points. So given the three distances, you could be at either one of these two locations. But which one? For that, we need a fourth satellite. If we know the distance from this one as well, say 12,500 miles, we get a fourth sphere. It intersects the previous three at a single point, and that's your exact location. So, to locate anything precisely on Earth, we require distances from four different satellites, which gives four spheres intersecting at a single point. And that is the simple math behind GPS, enabling us to accurately track everything from packages to airplanes.